Okay, hi Abigail, I figured it out. If we have the sequence 1, 2, 6, 24, 120, first we should check the common difference, which this has none, because the difference between 1 and 2 is 1, the difference between 2 and 6 is 4, the difference between 24 and 6 is 18, and this just isn't working. You could check a further step. If it has a double common difference, then it'd be quadratic, but this one doesn't have that either. It doesn't have a common ratio either. 2 divided by 1 is 2, 6 divided by 2 is 3, 24 divided by 6 is 4, 120 divided by 24 is 5. No common ratio, but it's got an increasing ratio. When you recognize this, this is a factorial sequence, because I know a sub n in general, the explicit, is n factorial. How do I prove it? If this is a sub 1, and this is a sub 2, a sub 3, a sub 4, a sub 5, when you see you have an increasing ratio, especially by a value of 1, increasing ratio of 1, 1, 1, then that's probably a factorial, because a sub 1 is 1 factorial, which is 1 times 1, or 1. A sub 2 is 2 factorial, which is 2 times 1, which is 2. A sub 3 is 3 factorial, which is 3 times 2 times 1, which is 6 times 1, or 6. A sub 4 is 4 factorial, which is 4 times 3 times 2 times 1, which is 4 times 3 is 12, times 2 is 24. A sub 5, a little longer, is 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 5 times 4 is 20, times 3 is 3 times 2 is 6, 20 times 6 is 120. So definitely the factorial sequence. So in general, if you wanted to find a sub, 13, that would be 13 factorial, which is 13 times 12 times 11 times 10 times 9 times 8, and da-da-da-da. This would take forever to multiply by hand, but your calculator has a factorial button. So if you just click in 13 factorial or the exclamation point, it's going to spit out our answer.